Okay, so I'm giving you a heads up right from the start that this video isn't for the faint-hearted. So I know you've seen a lot of squares, but here I just thought, well, what happens if we have a triangle? So the only thing we know about this is that the circles basically are as big as they can be to fit in an equilateral triangle, and that they have a radius r. So what is the area of the shaded region? So this is kind of an interesting little problem because it makes us think a lot about what's going on in these kind of systems. So I've marked this radius here, and what I'm going to do is I'm going to also mark down from the point down to the center of this circle. Now what I have now is a right-handed triangle, and this side is R. And if I imagine that this was an equilateral triangle, which it must be because this angle here is 30, and this thing is a right angle, so I've taken half of a 60-degree angle and a right angle, so this one here is 60. So if I build this out as an equilateral triangle, I know that this side here overall is going to be 2r, and that's going to be the same as these sides, so that this length here from the center of the circle to the tip of this triangle is 2r. So that means that I can work out this length here. And I'm going to call this length x. So this length x is equal to, if we think about it, this is the hypotenuse, and this is just one of the sides. So my length x, I'm going to say x squared is equal to 2r all squared minus r squared. This is just Pythagoras for a right angle triangle. And so this becomes 4r squared minus r squared, which I can take the factor r squared out. So this is, 4 minus 1, which is equal to 3r squared. So x squared is equal to 3r squared, or x is equal to the square root of 3 multiplied by r. So if I continue to think about this, I can say that this triangle here is also of length x. So now I just need to fill in the length of the middle bit here. And this here is r, and this here is r. So here, this is just 2r. So the length of one whole side of the triangle is equal to 2x plus 2r, and x is equal to root 3r. So this is equal to 2r plus 2 times root 3 multiplied by r. So I have a 2r in this case, which is my common term, so I can take those out. So this is 2r into 1 plus the square root of 3. That's the side of the length. So if I want the area of the whole of this triangle, what I need to do is I need to just work this same problem as I started out with here. So I'm going to draw this in green. Sorry, this is supposed to go between these two lines here. That's better. So this here is a right angle triangle. This is 60, and this one up here is 30 still. So my area of my triangle is equal to half of the base times the height. And I know what my base is here because this is this length of the side. What I need to do is I need to work out this length here, the height of the triangle. And this is actually very simple, but what we end up with is quite a lot of letters. Or quite a lot of numbers going on. And you can either work these out or you can leave them right to the end and work them out at the end. I'm going to leave them to the end. But hopefully, if you work this out yourself, you should end up with the same answer. So we know the size of this is equal to 2r into 1 plus the square root of 3. And that's the hypotenuse. And we know that this side here is equal to half of this. Just the same rule we had here. So now I need to find out this length here. And I'm just going to temporarily call this length here h for the height. So I know that h squared is equal to this length here squared. So this is 2r into 1 plus the square root of 3 all squared. And then I need to have minus this length here, which is equal to minus a half of 2r into 1 plus the square root of 3 all squared. And I'm just going to cancel these 2's here. So now I have r into 1 plus the square root of 3. So if I just look at this equation, I can say that h squared, and I'm going to factorize it. So r into 1 plus the square root of 3 all squared is common. So I'm going to take that lot out. So I'm going to say r into 1 plus the square root of 3 all squared into, this is 2 squared minus 1 squared. Yeah, because I've got to, I've got to keep this squared associated with this 2, and there's a 1 here, and 1 squared is just 1, so that's not much of a problem. So now I can say that h squared is equal to, so this is going to be 4 minus 1, so this is going to be 3 into r into 1 plus 3, the square root of 3 rather, all squared, which is the same as 3r squared into 1 plus the square root of 3 all squared. I'm going to just leave this like this, except I'm going to rewrite this as h is equal to the square root of 3r squared into 1 plus the square root of 3 all squared. And I can take this r squared out. If I take r squared out of a square root, I end up with r. So h is equal to r into the square root of 3 into 1 plus the square root of 3 all squared. I'm hoping you're all still with me. This is now the height here. So my area of my triangle, if I just change colour again, the area of my triangle is equal to a half of the base times the height. I've said this here. I now know what the height is. And so this is equal to a half. I need the whole of this base this time. So a half multiplied by 2r into 1 plus the square root of 3. Multiplied by my height here, which is all of this, which is r into the square root of 3 into 1 plus the square root of 3 squared. Which I can just multiply my r terms together and just collect everything together. Again, this 2 and this half are just going to cancel. So this is equal to r squared into 1 plus the square root of 3, whoops, wrong way for my bracket, multiplied by root 3 into 1 plus the cube root, sorry, the square root of 3. Squared here. So that is the area of my triangle. The area of my circles is equal to pi r squared, or I'm just going to have circle pi r squared, and therefore I've got 3 circles, so that gives me 3 pi r squared. So that means overall the area of the shaded region is equal to the area of the triangle minus the area of the circles, which is equal to, again, I'm just going to take this common term of r squared out, which is equal to r squared into 1 plus the square root of 3 into the square root of 3 into 1 plus the square root of 3 all squared, minus 3 pi. And I've run out of room for a number, but I'll fill that in when I've actually worked it out on my calculator. So I think that is 3.50 r squared. I hope you found this more difficult challenge a little bit of fun. And I shall be back with something that perhaps is slightly more related to your exam in just a little while.